Hi, my name is Thomas Ortner. I'm with the VRVis for 11 years now, and despite my elderly appearance, I'm a young researcher working on this dissertation. I'm responsible for the research and development of Pro3D, a 3D viewer supporting geologists in reconstructing the geological past of Mars. In this context, my colleague Rebecca will tell you now more about our most recent work on interactive correlation panels.
Hello, my name is Rebecca and I've been a researcher at VRVis for almost 2 years now. I am part of the team developing Pro3D, a 3D visualization tool mostly used by planetary scientists. This means we get to work on some pretty exciting projects, like helping explore Mars or supporting research in methods to deflect asteroids. In this video, we will show you InCorr, a tool that allows geologists to create so-called correlation panels interactively. Here we see a digital outcrop model, a 3D triangulated textured mesh of a rock outcrop. Geologists interpret these digital rock formations by tracing contacts between rock layers, as indicated by red and orange lines. They are especially interested in the orientation of layers to reconstruct ancient river flows supporting the search for signs of life on Mars. You can see disks with arrows where the orientations of crossbeds have been measured. A log is a summary of the geological properties of an outcrop. Logs can be very sophisticated, as you can see in the hand-drawn log on the left. With our collaborators, we agreed on a simplified blocky version on the right. To build a regional geological model, geologists connect contacts of similar layers across multiple logs in a correlation panel. Geologists draw correlation panels manually, which is very time-consuming, especially when they need to extend or correct parts of it. Instead of this rigid, tedious workflow, we want to let the correlation panel evolve with the geological analysis in a data-driven, interactive process.
We developed a 3D logging tool to connect the contacts that shall form a log. For this connection and the elevation of each contact, layers and their thicknesses emerge, encoded in the 2D log on the right. Then we assign a rock type to each layer, encoded in the layer's width and color. After selecting a layer, we can assign crossbed measurements to it. The orientations are then aggregated in a rows diagram. Repeating these steps for every outcrop, we arrive at the following correlation panel. To create a correlation, we select multiple contacts across the logs. The evaluation of our results indicates that InCorr reduces the time spent on logging and correlations from several days to a few hours.